Yes. So very good morning all. Today, our first major aim is to, talk about again the what? Again the parallax method. So what is parallax method, Midhun? Midhun, what is parallax method? According to you, Midhun, what is parallax method?
So the distance between the 2 points, sir.
Okay.
No, sir. That is
Distance
basis.
between 2 points. I think my screen is stuck, right? I think because in my
Yes,
video
sir.
it is not moving. So give me a minute. Midhun, you can talk about it. No issues. No issues. Midhun can talk about it. The So give me a minute. Let me see. Okay. Now it is movable. So Midhun, please, go ahead. Hello, Midhun.
Yes, sir.
So you may go ahead. What is parallax method?
Sir, to measure the distance, sir, of the planet from a point.
So in order to measure the distance between celestial body, the method of parallax is used, right? So the method of parallax is used for that. Now you may write that here the if yesterday I told you that is there is an angle.
Sir,
Yeah. Yes, please.
sir, after which point we should be writing this, sir?
That I will tell you. First of all, the anomalies that are happening on the screen, let it come to an end. I think you can see a blue circle here, right? So I'm waiting that
Yes,
to
sir.
just let it get closed. Just
Okay, sir.
give me a minute, okay? So I'll write it here. So if thing to say is that I have drawn a line here. Let me see. Put the parallelatic angle, right? Hmm? The angle. Hello. Yesterday we talked about the parallelatic angle, right? What is
Yes,
par-
sir.
Yes.
what is parallelatic angle? The angle that is subtended between the two geometrically angle, which is subtended between what? Between that is subtended between the two geometrical ends is actually known as parallelatic angle, right? So that parallelatic angle is sometimes it is also called as angular diameter. That parallelatic angle is also sometimes called as angular diameter. Why it is called how it is called as angular diameter? Just a minute. I think this anomalies will end now. No. So there is no chance for that. So I'll sharing my screen and and I will do what I will write it on the Zoom. So that particular angle theta is that is called as
Sir,
what?
your voice is breaking in between, sir.
Parallelactic angle.
That parallelatic angle, that is parallelatic angle. So what I want you to understand is that that parallelatic angle is also called as what? That parallelatic angle is also called as, I think my screen, well, yeah.
Yes.
Now what will we share it to you? So if we have made the observation, suppose this is Earth, okay. This is Earth. You have made observation to this particular planet. So, you made the observation from both diametric ends. Then there is an angle here, right? Hello? Then there is an angle, right? So this angle,
Yes, sir.
so
Yes,
this
sir.
angle is actually called as the angular diameter. So in terms of angular diameter, how we can write it? In terms of angular diameter, alpha is equal to what? Alpha is equal to the diameter of that particular planet divided by the distance. Alpha is equal to small d divided by capital D. Alpha is equal to what? Small d divided by capital D. That is what I wanted to convey with you. So just give me a minute. Without putting any animations and all, I will share the screen to you. So, you may write like in the case of, you may start writing like this in the case of below, the
Sir,
method.
yesterday we concluded up to d is equal to b by theta. Sir, after that we can write what you're saying now, sir.
Yes. After that, you may write it in the case of, in the case of angular diameter. In the case of angular diameter, the above equation becomes, have you numbered that equation of for theta? Theta is equal to,
Sure, d is
yes. So the above equation can be written as, theta is equal to small d divided by capital D, right? So instead of theta, you may write here it as alpha. Alpha is equal to small d divided by capital D.
Sir, what is that small d and capital D?
Small d is what? Small d is the length of the circle, which means it is the diameter, like I told you here, right? Suppose you are making observation to a distant planet from both the diametric edges of Earth. And there will be an angle that is subtended here, right? That angle is alpha, and the distance from here to here is small d, and this distance is what? Capital D. Got it?
Sir, can you say it once again, sir?
Yes, why not? Pravesh, suppose this is, I am representing our Earth as in a circle. Okay. So you are standing here. In between, there is, another planet. Here is also the another diametrical end. So you're making observation to this planet from here. So there will be a line, right?
Yes,
And
sir.
here also you're making from here also, if you're making another observation, there will be another line. So if both the lines at the point where both the lines meet, there will be an angle. That angle is actually what? Alpha, or the angular diameter. Okay. So
Okay, sir.
if we joined these two lines, A and B, we will get the diameter of this particular planet from where we are making the observation, right?
Oh, yes, sir.
So if this is capital D, then also we can use what? Then also we can utilize this method to find out capital D or alpha or small d according to our convenience, right? If we know any of these two, the other
Yes, sir.
we can be found out, right?
Yes, sir.
Got it?
Yes, sir.
Okay. Any doubts? Anyone? So yes.
No, sir, no doubts.
Okay. So yesterday we stopped up to this. Let me introduce another new slide here. So now we are going to do is what? Now we are going to devise, a methodologies, or, or now we are going to talk about how to measure what? How to measure the distances, or, the smaller dimensions. So I hope you know that from by studying chemistry itself. I think you are very aware about that. The nucleus is, if we take the ratio of atom to nucleus, okay, atom to nucleus, which means size of atom divided by size of nucleus, that is equal to 10 to the power 24, which in turn means that atom is 10 to the
5 times difference.
Yes,
I think 5 times difference.
it is 10 to the power is just a radius size I'm talking about. It is almost 10 to the power 24 times. So that is, it is
24 24, what's that? 24 meters or
10 to the power 24 times, not in meters.
Oh, okay, sir.
So it is this much bigger than what? It is this much bigger. So what I am meaning is that since I hope, so from this ratio itself, it is very clear that the nucleus is much smaller in dimension that of the size of an atom, right? Hello?
Yes, sir.
Yes,
So
sir.
what I want you to understand is that there are n number of methodologies that are already available to measure what? That are already available to measure the very smallest distance up to the largest distance. Here I meant the very smallest distance as the dimension of the nucleus, which is 10 to the power minus 15 meters, or it is expressed in a unit called as 1 Fermi. And the largest distance which we can measure is the intergalactical distance. It may be, vary to 10 to the power 27 meter or something like that. Okay. So, this is the range. Up to this range, we have methodologies to measure the huge distances. So this is what we are going to talk today. So first of all, since we are in the atomic dimension, yesterday also we talked about what? We talked about the tunneling microscope, right? So how it was working? Hmm? How it was working? That is, it was used to measure the size of atoms. So similarly, now also what we are going to do is that, we are going to devise a method to measure the size of atoms. So you have to suppose we are going to, do an experiment here. Suppose you have taken some water on a trough. Trough means, something which has a shape like this. Okay. In this trough, you have on the surface, you have, placed the lycopodium powder, something which is called as lycopodium powder. And, you have prepared the mixture of, oleic acid and alcohol here. Okay. Oleic acid and alcohol as another mixture. And you are placing n number of drops on this surface. Okay. Let the volume of each of the drop be capital V. Any doubts up to this?
No, sir, no doubt.
So then the total volume of the molecules that spread on the surface of water will be what? That will be equal to, you have placed n number of molecules and volume of each of the molecule is V. Then the total volume occupied by each of the drop of oleic acid and the mixture of alcohol, it will be very simple. I'm asking a very simple question. 5 pence. For each pen, it is 5 rupees. The total is 25 rupees, right? N number
Yes,
of,
sir.
similarly, n number of molecules are placed on the surface, and each
Into
has
their volume.
right.
Number of molecules into their volume of each
Yes.
molecule.
Number of molecules multiplied by volume of each of the molecule, right? And this molecules are what? This molecules are actually what? These molecules are, they are, since they are placed inside a trough, they are what? They are two-dimensional, or they only have a very smaller area to occupy. So what I want you to understand is here is that here the thickness of these molecule will be equal to what? This thickness. Suppose if T represents thickness, this thickness will be equal to area. Okay. That thickness will be equal to area. So if you divide it by the total volume divided by area, or the total volume divided by the thickness, then you will get what? You will get the approximate size of molecule, right?
Yes.
You will get the approximate size of the molecule. So this is one of the methodologies which we have discussed. Any doubts on this? I just want you to hear it. This has no importance at all. It is a part of NCERT, so we discussed it. That only it is there. Any doubts?
No, sir.
No, sir.
Okay. Now, from here onwards, give me a minute. So this is what it says. Just a minute. Size of a molecule is estimated by a simple method. Oleic acid is diluted in alcohol and a non-concentration is prepared. Lycopodium powder is spread on water surface, and similarly, n drops of each of volume V is placed, and the drops are to be thin. So that means the diameter of thin film 2 gets its area. And similarly, if we divided the volume divided by area, what we will get? We will get the size of the molecule. So now we will do an MCQ. So for that particular purpose, I need to again go to the slideshow or something. Let me see whether this will work or not. Okay, this will work. I think for the time. The larger distance of a planet.
Yes, sir.
The larger distance of a planet or star is measured with the help of what? Who will answer this question? It's very easy.
Parallax.
Parallax
Parallax
method.
Parallax method.
Parallax.
Parallax method, right? So that is the answer for this one. And give me a minute. Size of a molecule can be measured using what? I already, placed the answer.
Tunneling
Microscope.
Tunneling microscope is the answer. Simple microscope and compound microscope, or the regular microscope. Using that, we will be only able to measure what? We will be only able to measure the dimensions that are physically recognizable to us, or the things which are physically recognizable to us. Okay. That is why the other three microscopes are used. And can someone tell me what is the major limitation of these three microscopes which are mentioned in the options A, B, and C?
Sir, they need light to work, sir.
Yes. So, their resolution. Resolution means that their clarity, in a simple words, that depends upon the wavelength of light. So that, since the wavelength of light is very small, sometimes, we cannot find out some things that which are which are having bigger dimension than light, and which are having smaller dimension than light. So in order to increase the resolution only, we have devised something called as tunneling microscope and electron microscope. Tunneling microscope and electron microscope are the same, and also there are scanning tunneling microscope. I just told you some facts. Okay. So what I want you to understand is that in order to measure the smaller dimension, we use what? We use tunneling microscope. So now we are going to about what? We are going to talk about ranges of length. So, size of an object, like I said, size of an object come across the universe vary over from word to word. 10 to the power minus 14 to 10 to the power 26 meters, or else, the dimension, like I said, 10 to the power minus 15 to 10 to the power minus plus 27 meters. Up to this may it also vary. That means from the atomic dimension to intergalactical distances. Okay. And also we have, so according to our convenience, what we have to do, we have to use the particular units, or the particular dimensions to measure what? Dimension to measure that distance. Okay, clear up to this? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
So, these are the ranges of length. That is 1 Fermi. 1 Fermi is equal to 10 to the power minus 15 meter. I'll tell you where it is used. It is used to measure usually to the express nuclear radius. Radius of a nucleus is expressed using this unit Fermi. So 1 Fermi is equal to what? 10 to the power minus 15 meter. So by writing the heading ranges of length, you may note this. 1 Fermi is equal to 10 to the power minus 15 meter. Below, you may write it like this, that this unit is used to measure or to express. It is used to express radius of a nucleus. Done.
Yes, sir.
Okay. So the next one is Armstrong. Armstrong is represented as 1a to the power 0, or 1 Armstrong is represented by like this. It is 1 Armstrong is equal to 10 to the power minus 10 meter. 1 Armstrong is equal to 10 to the power minus 10 meter. So any idea where this will be used?
No, sir. Never heard, sir.
Okay, this actually is used in order to express wavelength. So you may below you may write it like this. This unit is used to represent what? This unit is used to represent the wavelength, diameter of atoms, not nucleus. Okay, diameter of atoms.
Sir, which we can write now, sir?
Yes, which you have to write now. Whatever
Okay,
I am
sir.
saying,
This
you
also,
have to. Yes, Devastri.
which you show on screen after you dictate, we need to write that one, sir.
Yes, you have to. Done?
Sir, again.
Sir, diameter of?
It is used to express the diameter of atom.
Sir, Fermi is to measure the radius of nucleus, no, sir?
Yes. Clear up to this?
Yes, sir.
No.
Yeah, sir. Yes, sir.
So the third one is the astronomical unit. So
the second what it is used to, sir?
One Armstrong, it is used to express wavelength. Wavelength can be expressed in the unit of Armstrong. For have you ever heard about electromagnetic waves? Mobile radiations, those are electromagnetic waves, and light itself is also an electromagnetic wave. So wavelength of such kind of waves can be expressed in terms of the unit called as Armstrong.
Okay, sir.
So, the next unit is one astronomical unit, and one astronomical unit is the average of distance between Earth and the Sun. Okay, average of distance between Earth and Sun is known as one astronomical unit. So, kindly note that. And this one astronomical unit is equal to 1.496 multiplied by 10 to the power 11 meter. This astronomical unit is equal to 1.496 multiplied by 10 to the power 11 meter. So if it is done, just let me know, because I have played. Just a minute. I have unfortunately I closed it. Give me a minute. I had, parallax. I kept the animations in the another Google tab. Just give me a minute. Okay. For the parallax, and also for, there is another distance which is called as parsecond. Okay. So I had kept it here. Give me a minute. One astronomical unit. Okay. There's an image. Just give me a minute. By the time you may write about parsecond also. Okay. What is parsecond? So, I'll explain that also through this animation. By the time you may write about parsecond. Okay. Just give me a minute. Okay, I'll share. Is it written? Hello? About
1
parsec.
minute.
Okay, take your
Yes,
time.
sir.
Completed, sir.
Okay. And by the not in the end, I'll ask you after showing this one question. You have to find it out.
So that whole slide we need to copy, sir.
The whole slide you were supposed to copy up to parsecond, the definition of parsecond also. No, don't worry, we
So
can
will you
copy.
show that again?
First of all, let us explain that. Okay, what is meant by astronomical unit and what is meant by parsecond. I hope this figure is visible, right? This one,
Yes,
where
sir.
the hand symbol is there. So what the astronomical unit is, it is very simple. The astronomical unit is, it is the average of the distance between Earth and the Sun. It is one astronomical unit is represented here. And suppose, if we are measuring the distance from Sun to any other star which is not present in our universe, okay, or you have heard about the clusters of stars, right? So if you are measuring into any other dimension, okay, if you are measuring the distance from Sun to any other star which is present in any other dimension, okay, and if we are drawing a line from Earth, this from the center of Earth to that particular star, at the distance at which this angle that is formed from the or that is formed between the line which is drawn from star Sun to that particular star and from Earth to this particular star, if that angle is 1 degree, okay, the distance at which the angle between these two lines will become 1 degree, or sorry, 1 radian, so that it will become 1 radian. That particular distance is called as what? That particular distance is called as parsecond. So I will repeat it again. If you want to know about parsecond, just imagine this. That is, there is another star in another dimension. Okay. So for you will draw a straight line from Sun to that particular star, and also then what we will do, we will draw another line from Earth to that particular star. So the distance at which the angle between these two lines becomes 1 radian. So that that particular distance is called as parsecond. Any doubts on this?
No,
Hello?
sir.
No, sir, no doubt.
No, sir.
Every second it changes, sir, the value, or value is same, but
No.
just
This
position changes.
value is a constant because the distance at which the angle becomes 1 radian. Then that distance is only known as parsecond. If it has become 2 radians, then that is changed. Or it is we may express it as a multiple of parsecond, 2 multiplied by 1 parsecond. Like that only we
Okay.
express. So parsecond is the basic unit. Okay.
Sir, the star is a fixed star, or the star we take for reference
Are
is
you
a
talking
fixed?
about the position of the star? It will be almost fixed, not exactly almost, but there may be a
Okay, sir.
slight variation depending upon the orbit and many other factors. Okay.
Okay, sir.
Okay. So this is all about what parsecond also. So that the parsecond is what? Parsecond is what? It is the 3.08 multiplied by 10 to the power 16 meter. I request you to, for all the students to study this value 1 2 this 3 values. And what about like light year? We have heard about what we have heard about, the velocity of light is equal to 3 multiplied by 10 to the power 8 meter per second. This is the highest velocity that is known to us, right? Hello.
Yeah,
Yes, sir.
sir.
The fastest
So
thing to travel is light.
yeah, so let me ask you one question. How the sunlight reaches to us? Jiva.
It takes 8 minutes to reach, sir.
Yeah. Just a minute.
When it reaches atmosphere, there is atmospheric refraction.
Okay.
Sir, I can't see the screen, sir.
Yeah, I have disabled the screen sharing. I will reshare it again. Before that, I need to ask you a question. Hello, Jiva.
Okay, sir.
Where is Jiva? Jiva left the meeting. No.
Yes, sir.
So Jiva, please tell me how the sunlight is able to reach to Earth. How it reaches Earth. I don't want the time or any other measurement. I don't want the the cut to cut answer. What you know, you just tell me. So from there, we will make the answers and other things.
Sir, repeat the question again, please, sir.
Okay, sure, I will. So what I want you to tell me is that, how the sunlight is able to reach to Earth.
Sir, can I try, sir?
This is her chance. Let her do it. After that, I will give you. Okay. Hello, Jiva. Am I audible?
Sir, through rays. Through rays, sir.
Through rays. Okay. So in the form of radiation, it is reaching us, right? So this radiation has to have a particular, a particular velocity, right? So these radiations have a particular velocity. That velocity is known as velocity of light, and that is 3 into 10 to the power 8 meter per second. So what I want you to understand is that, Shane, then I'll give you a chance. What is meant by light here according to you?
Sir, the distance light can travel with the same velocity in a year, sir.
Yes, that is what a light year is, or the total distance traveled by light in an year is called as light year. Okay.
Yes,
so its value is what? Its value is 9.45 multiplied by, 46 multiplied by 10 to the power 15 meter. Okay, 9.46 multiplied by 10 to the power 15 meters. Any doubts up to this? Anyone?
No, sir.
No, sir. No, sir.
Sir, light year is just a distance, sir. No speed, sir. It is just a distance.
Speed. It is the total distance travel. Never confuse it with the speed. Okay. So
Okay,
I'll again simply tell you, here also the 3 multiplied by 10 to the power 8 meter per second means that in a second light will travel this much distance. Okay. In a second light will travel this much distance. That is what actually meant by this. And I think we are going into a timeout. So I will end the meeting now. And I request the other students who are having an issue with their range or connectivity, if they got in between, cut from the meeting, they are supposed to inform. Got it? So now I will end the meeting and I will again share the link. Okay. So I hope.
Okay, sir.
Okay. So I'm going to end the meeting.
Okay, sir.